In this problem, we're asked to find the vertex of a given quadratic function. In this problem, our function is x squared plus 4x plus 3. And to begin this process, we want to clearly identify our a, b, and c value. A being the assumed 1 coefficient of the quadratic term, b being the coefficient of the linear term, in this case 4, and c being the constant term, which is 3. So we now clearly have outlined our a, b, and c values for this problem. And we have to recall that there's a formula that tells us the x-coordinate of the vertex. And that formula is the opposite of the b number divided by 2 times the a number. So for this problem, we're going to insert our numbers. And again, the opposite of the b number, our b number is 4. So the opposite of that would be negative 4, divided by 2 times our a number, and our a number is 1. So if we do the math, first doing the multiplication in the denominator, so 2 times 1 is 2, and then the division, negative 4 divided by 2 is negative 2. So we find that the x-coordinate of the vertex is negative 2. Now what we want to do is find the y-coordinate that goes with it, and we can find the value of the function when x equals negative 2 by inserting negative 2 everywhere there's an x in the problem. And notice the x occurs in 2 different places, in the quadratic term as well as in the linear term. So we're putting in a negative 2 that's being squared, and we're also putting in a negative 2 that's going to get multiplied by 4. So evaluating this expression, we start with our exponents. We want to square our negative 2, and of course negative 2 times negative 2 would make for a positive 4. We have to be careful with our negatives. And then we'll just copy the rest because there's no other exponents. Next, we'll do our multiplication. So we have a 4 times negative 2 in the middle here, so 4 times negative 2 is negative 8. So we get 4 minus 8 plus 3. Now, adding and subtracting, just going left to right, so 4 minus 8 would get us a negative 4, plus that 3 will get us a negative 1. So the conclusion, putting this together, the vertex, which is a point, has an x-coordinate of negative 2 and a y-coordinate of negative 1. And now we can take a look at what that looks like on a graph to confirm our information. So now with the graph in front of us, we can clearly see that that vertex is right here at negative 2, negative 1. That's the turning point for the parabola. Now let's try another one. So in this problem, we're going to have a different quadratic function, 2x squared minus 4x plus 1. So we're going to start in the same manner. We're going to identify our a, b, and c values. So our a, the coefficient of the quadratic term, is 2. Our b is negative 4. And our c is positive 1, or just 1. So we're going to follow the same procedure. We'll use the formula the opposite of b over 2a to find our x-coordinate of the vertex. In this problem, the opposite of the b number, well, our b number on this one's negative, so the opposite of that would be a positive 4, or just 4, divided by 2 times a, and our a number is 2. So again, doing the multiplication in the denominator first, 2 times 2 is 4, and then 4 divided by 4 gives us 1. So we get a 1 coordinate, x-coordinate for the vertex. And now we're going to insert 1 into the problem. 2 times 1 squared. Everywhere there's an x. Again, 2 locations on this problem. That is, we're putting in 1 here in the quadratic term, being squared and then multiplied by 2, and 1 in the linear term, being multiplied by the negative 4. So if we do the order of operations, we'll do the square first. 1 times 1 is still 1, so that doesn't change very much, other than we lose the square. Then we'll do our multiplications. So 2 times 1 gets us 2, and negative 4 minus 1, or negative 4 times 1 gets us negative 4. and then adding left to right, 2 minus 4 gets us negative 2 plus 1 for a final result of negative 1. And putting this together, our vertex for this problem is 1 for the x-coordinate, negative 1 for the y. Now let's take a look at the graph and see what that tells us. So here we have the graph, and we can see that the vertex of 1, negative 1, right down here, over 1 and down 1, is our turning point for this parabola.